Okay, this is the only section we're doing in chapter 4. And it's like section 4.1. So when light strikes an object, and then it's going to talk about color and things like that in this section. So when light strikes an object, there are different things that can happen. It can either be reflected, absorbed, or transmitted. So there's 3 different things that can take place. And this guy is holding the tray here that shows you the different things that can happen when light strikes an object. If the object is opaque, this reflects or absorbs all the light that strikes through it. And what happens with something opaque is that you cannot see through it. So something like milk, if you put milk in a glass, it looks like he's got milk in his glass there, that's opaque, which means that it absorbs that light that strikes it or reflects it all back in this situation, and when that happens, you cannot see through it. So opaque means I can't see through the material. Okay, the other 2 things that can happen are the other 2 ways that can work with light striking an object. So something that transmits light or something that scatters light as it passes through. So transparent means that it transmits light perfectly through it. You can see through the object. Translucent means that you can see through it, but you can't see clearly through it. A lot of times windows and offices and things like that they want the light to come in, but they don't want to be able to see inside the office. A lot of times they'll have translucent type material on the window. Our old doors from school, for the longest time, they had a couple panes, if I'm not mistaken. At least one pane in that door was translucent, which meant the material just scattered light, and then we had also a transparent part to that as well. So translucent means it scatters the light. It doesn't necessarily let it shine through, but it shines through, it just doesn't shine through clearly. Okay, so something that goes along with light striking an object is that you can see the object. So in order for us to see anything, light needs to be able to strike it, and it usually reflects off it. And it reflects off based on the color of light that reflects off of the object. So all the other colors are absorbed, and the only light that is reflected off of it is the color that the object is. A black object, all the light is absorbed. In a white object, all the light is reflected. So you might have heard someone say before, maybe you've heard this before, that if you wear like black outside, or if you wear all black in a certain situation, and you might get warmer. And the reason for that is all of the light is being absorbed. So if you're wearing black outside and it's a hot day, you're absorbing all of the light out there. So, your t-shirt or your sweatshirt is gonna heat up a lot faster. If you're wearing a light color or white outside in that situation, same situation, all the light is reflected off of you. So when something is white, all light is reflected. When something is black, all light is absorbed. So this is pure natural light. This is how that works. But otherwise, the color that you see is the color that is reflected off of the object. And we also can have objects in colored light. There are such things as colored light bulbs and things that have some sort of filter over them that allows for only a certain amount of light to get through. And when that happens, depending on what color it is, you're going to just see whatever is that color in that light. So for instance, they're showing an apple there. An apple is red. And so an apple, if it's shined under a red light, it's going to reflect that red light, and you're going to still see the red. The other 3 objects in that, if they're not red, are going to appear black. And the second one with the green, the leaves appear green, which they are, and so they reflect that green light. But the red apple absorbs all the light because it doesn't have any red in that light, and so it appears black. And if it's in a blue light, all of it appears black because there is no color on it that will reflect. Same thing when you have color filters, the same basic idea happens there. So it's just going to reflect the light that it has. So like if it has that particular color in it, it will reflect the light and it will appear that color. If it doesn't, same thing. It's just going to absorb it all basically and look black. Okay, so combining colors, and you've probably done a lot of this in art class. This shouldn't be any news as far as pigmentation is one of the things we're going to talk about, but then we're also going to talk about colors of light as well. So for coloring, putting colors of light together, we can produce any color by mixing colors of the spectrum in varying amounts, which you probably have done. You probably mixed colors before. But primary colors are colors that are used to make any other color. Your main ones are going to be red, and then yellow and blue are going to be your main primary colors of light. Okay, so secondary colors are when you put 2 primary colors combined in equal amounts to produce these. So for instance, orange is a combination of red and yellow, and green is a combination of yellow and blue, and purple is actually a combination of red and blue. So we can combine colors of light, which help us to produce different colors. So any colors that are going to be produced, any color that's going to be reflected is a combination of two colors put together in varying amounts to produce the colors that you're looking for. So like I was saying, the primary colors of light are red, green, and blue. When they're combined in equal amounts, the primary colors produce white light. Now, secondary colors of light, we're talking about different light colors. They have light bulbs with filters on them. A little bit different if we're talking about someone who's done some stage work and you kind of know about the different colors of light for that. You'll know that the secondary colors of light, red and green, produce yellow. When we're talking about combining colors of light, cyan is green and blue, and magenta is red and blue. So you kind of have your secondary colors when we're talking about light as well. Complementary colors are colors that combine to form white light. So these types of things come together and form that. Pigments are slightly different. Pigments, we're adding colors to each other. And when we do that, we actually start to kind of cover up some of the colors. So as we mix a couple colors together, we'll get different colors. If we mix all the colors together, we get black. Okay, so it's not like before where if we have all the colors together, we have white light. And when we're talking about pigmentation, all pigments together give us black. So pigments are substances that are used to color other materials. So as we add more pigments, fewer colors of light are reflected and more absorbed, which allows us to see darker colors. But if we get them all together, we end up seeing black, which is basically the absence of color because all the colors are going to be absorbed. So as more pigments are added, sorry about that. So primary colors of pigments are cyan, yellow, and magenta. So these are pigments. We're talking about pigments when we're doing art, like we're painting something. Our primary pigmentation for those are cyan, yellow, and magenta. If we mix them all, we get black. So secondary colors of pigments are red, which is magenta and yellow together, green, cyan and yellow, and blue, magenta, and cyan. Pictures are made of tiny dots of colors of ink. So different pictures, we're talking about, especially if you have an old television, you would notice this as well. Our newer plasma type televisions don't show this, but if you have an older television, you will see that there are equal amounts of red and green and blue dots that kind of come together to form all of those different colors. This is the very last section that we're going to be doing this year. Crazy. But this is in your packet. It's also available in PowerSchool Learning. The worksheet is. Send it out to parents as well. There will be kind of an end-of-year activity that was available. And if you don't come to one of the Zoom meetings, we'll probably work on that together. And instead of having the final, that's what it's going to look like. So enjoy.